In this video, we're going to take a look at some of those questions that have circles and triangles in them. So we start by looking at this first question here, question 7. And it says, the diagram shows a circle with center O and radius OK. So there's your radius. It's the same as the way that would be the radius, or that would be the radius, or that would be the radius, or indeed, or that would be the radius as well. But they're telling us that OK is the radius. We would obviously need to be able to identify that OT is also a radius, because it starts at the center and ends on the edge of the circle. So if OK is a radius and OT is also a radius, well then the lengths of those two lines are the same. Now that'll come in handy later on in the question. But in the meantime, first question is to ask, they're asking is to find OK. This bit here. Well, like I said a moment ago, OK is the same as OT. Now, it would be impossible to just find OK straight away. Because if you break that triangle away from the circle, so to give yourself a clearer look at it, where T is up here, P is here, O is here, and K is here somewhere, it's a right angle triangle. We know this because it's a tangent. So it's a right angle triangle, and it even looks like a right angle triangle. Now in a right angle triangle you can find the different sides. You could find this side, you could find this side, you could find this side using the Theorem of Pythagoras. But there's no rule in trigonometry to be able to find a little bit of a side. So that's not going to work. But what you could do, like I said a second ago, is you could find OT, and that's the same as OK, because they're both radiuses, or radii, so they're both equal to the same thing. So with that in mind, let's fill into the little diagram here the bits that we do know on that triangle. We're told a couple of things. We're told that PO is 13. So all of this side here is 13. And that PT is 12. So all of this side here is 12. And we don't have this side OT, so we can call that X. Now it's simply a straightforward right angle triangle that has two sides given, and we're missing a third, so we use the Theorem of Pythagoras. H squared is equal to A squared plus B squared. We start off by labelling the sides. The one directly across from the right angle is H, and the other two sides are A and B. And then we sub those values in. So this is going to be 13 squared. This is going to be X. And this is going to be 12. You can put them in the brackets if you want. Type it out on the calculator. 13 squared is 169. X squared is X squared. 12 squared is 144. Get your numbers onto one side. So let's move this over here. It'll be 169 minus 144. Do that on the calculator or in your head and you get 25. And then of course just remember you have to square root it. So we found what X is. So we now know that this side of the triangle here is 5. And like we said a moment ago, if that's 5, well then that's 5. They're the same because they're both radius. And in the question you're asked to find OK, which is that side. So OK equals 5. Now they want to find pk. pk is that little bit there. Well, you just found out that this bit was 5. You knew that because you found this bit to be 5. And if that bit is 5, and the whole thing is 13 along that side, well then the bit that's missing, well, it's 8. Yeah, because 8 and 5 make up 13. Now how would you show that? You'd say pk is equal to 13 minus the bit you know of, minus that bit. So pk is equal to 8. And that's that one done. Now in the second question, so in this question, I'm just going to rub this bit out so that we don't mix up which one we're doing. There's a lot of similarities between the one you just did. It says a circle with center O and radius OP is shown. OP is this bit of it. And just at first glance, you can see OP is going to be the same as OR because they're both radiuses. They're both originating at the center and extending out to the edge of the circle. So they're both 7. That might be important in a moment. So A is a circle with center O and radius OP. T is a tangent to the circle with a point of contact at P. Now, it's just a straight line, but they tell you it's a tangent because tangents form right angles with the radius. They always do. So we know that that triangle there is a right angle triangle. So when it's a right angle triangle, it's a lot easier to find things because we can use the Theorem of Pythagoras. You can only use the Theorem of Pythagoras in right angle triangles. That's why they're telling you it's a tangent, so that you'll know that that angle there is a right angle. OP is 7. Yeah, that's there. And PS is 4 root 2. That side there. Okay. Find OS. Okay, so all of that. So essentially, we have a triangle. A right angle triangle. We can ignore the circle for the time being. We've been given 2 sides of that triangle, and we're being asked to find the third side. So we use the Theorem of Pythagoras. Label the sides, so that's H, and we can call that one A and that one B, or you can call the other one A and the other one B. It doesn't make a difference. The only thing that matters is we do H correctly. And we're going to fill them into the Theorem of Pythagoras formula. So this time we don't have H. That's where the brackets come in useful for the likes of that. 4 root 2. You have to use brackets for that really. Otherwise it might confuse the calculator. What do you get when you put that into the calculator? You get 32. That means add them together, you get 81. And of course, don't forget your root. So this time we know that x is equal to 9. So now we have this part of the we have this part of the triangle here, down along, all the way down to there. We know now that it's 9. And that's OS, by the way. So there's no harm to write that in. OS equals 9. Rather than x is equal to 9. Because that's the first part of the question. That's part I. Now part 2, we're looking for RS. RS, if we just rub out all these different colours here. RS is just that little bit there. Now remember, we just found out that all of this was 9, all of it, from O to S. We also realized earlier that this is 7, because it's the same as this. They're both radius. So that leaves that little bit at the end, here. And of course it would be 9 minus that bit to find out what that yellow bit is, which is RS. So RS, this is part 2. RS would be 9 minus the 7, minus the radius. So it's 2. Okay, so RS equals 2. Are we told if these are centimeters? We are, so we should really put in centimeters into our answers. Centimeters. Now part 3, find the area of the triangle, that symbol there, the triangle OPS. And now there's only one triangle in there, so they want you to find the area of that triangle. Now it's a right angle triangle, and you've been given the sides. So in that situation, it's simply the old formula, half the base by the perpendicular height. Okay, now we're given the triangle like this. Okay, it looks like this. Right angle in there. We're told 7. We're told 4 root 2. And we've just worked out that this is 9. Looking at it like that, it's kind of confusing to understand which part is the base and which part is the height, because it's kind of sideways. So in that situation, rotate the triangle so that it's sitting on its base, sitting on a flat part, with the perpendicular, with the right angle pointing straight up. If we did that, so that's what it used to be, that's what it looked like in the question, but we just rotated it this way. So now 7 is here, and 4 root 2 is there, and 9 is up here. Just so that it's clear, we just made that side, we turned it on its side basically. So 7 was there, that bottom part, that side part became the bottom part. We just kind of rolled it over onto the right, and it is now there. Okay, but why did we do that? Well, it's much easier to identify now a base and a perpendicular height, a straight up height. Okay, we don't use 9 as a straight up height because it's not going straight up, it's slanted. So it's half the base, which is 4 root 2, by the perpendicular height. That's 7. When you type that into the calculator, you get 19.8 centimeters squared, because of course they're looking for area. And if you're ever asked for area, you must remember to square the units at the end. Okay, I think that's what it is on the calculator anyway. So that's those 2 questions. They're not too bad once you separate the triangle from the circle and use whatever information you can to fill in other stuff. So if that's 7, well then that's 7. So that's why it was in a circle, by the way. It was in a circle to give you that little piece of information. The same with the one up there. Like, you just have a triangle there, so you think, why can't I just use the Theorem of Pythagoras? But you needed that other piece of information that being in a circle gave you, that OT will be the same as OK, because they're both radiuses. Okay, that's it.